Welcome back at C square. In this lesson we'll talk about density, and you see here a definition of density. Density represents the quantity per unit volume, unit area, or unit length. In this lesson we're gonna look to the first two, but it's kind of the same thing for the unit length. Oh, let's see this first part, density, when density is represented as quantity per unit volume, and that density. That type of density you use a lot when you talk about chemistry, physics, metals, right? For example, if you take a look, I have here gold and silver, and you see the density. This number here seems different, however, they represent the same thing. Be careful, the units are different. That's the reason the numbers are different. The same for silver. If you notice, two ways to see, at least two ways, the density of silver, lead, and copper. Also the same way. These four different metals can help you to remember this formula. Density D equals mass over volume. Okay. Sometime in some classes, instead of D, you see a different letter, the Greek letter rho. Okay, so let's see the first example. We have here a block of gold with a mass of 9,660 kilogram and a volume of 0.5 cubic meter. We need to find the density of gold. So this is a straightforward problem. I'm gonna have to remember density equals mass over volume. And we have here 9,660 over 0.5. Now, if you want to put the units, that will be good. It helps. Cubic meter, it's this way. It means the same thing. So let's grab a calculator. In case you can, 9,660 divide by 0.5. That is a math that you can do without a calculator, obviously. Multiply by 2, 9,660. And that will be 19,320 kilogram per cubic meter. Okay, if you go back to my previous slide, 1 minute ago, you're gonna see the density is pretty close to what I said. Okay, but in this case, you notice we have the mass and the volume given, we can find the density. That is the idea of this problem. In my second example here, you will see it's very similar. We have a cube that each side measure 3.9 centimeter and its mass is 95.8 grams. We need to find the density. So again, what do we do here? Density equals M over V. M stands for the mass. We have it, 95.8. The only thing we do not have is 95.8 grams. Is the volume, but this is a cube. So the volume of a cube is the side raised to the third power, side times side in this case, another way. So that will be 3.9 raised to the third power. I'm gonna grab a calculator and do this math. 3.9 to the third power, and I end up with 59.319 and let's put a unit. This is going to be cubic centimeter. So now we can go back to this formula and we have the mass 95.8 grams over 59.319 cubic centimeters. So again, a calculator will be very useful here. And let's do this division. 95.8 divide by 59.319. And that will be 1 point rounded to the nearest hundred. So I'm going to round it to the nearest hundred. 1.61. That I will do gram per cubic centimeter. This is the answer for this problem. On this next problem, you will see it on that density formula sometimes we have to play with. The volume of a ball is 768 cubic centimeter, and its density is 3.2 gram per cubic centimeter. So in fact, I like this problem for this reason, 3.2 gram per cubic centimeter, because if you do not remember the density, then that will help you to find the formula. The density equals mass over volume, because grams means mass, cubic centimeter means volume. So that will help you, I guess, to remember the formula. And now in this formula, we're gonna plug what we have, 3.2. You can put the units. We don't really need it since we notice it's cubic centimeter and cubic centimeter here, so no really need it. And the mass is the thing we need to find, so I'm gonna keep it here. And the volume is 768 cubic centimeter. So you notice in this case, a little bit different than the previous two, we have the formula and we end up with an equation. In the other we just evaluate. So how do you solve an equation like this? Multiply by, in this case, 768. Why? Because you're going to cancel this 768. And you're going to have to do the same thing on the other side. So we have m, the mass, equal. And now let's do this math with a calculator. 768 times 3.2. And that will be 2,457.6. Of course, it will be good if you remember the unit, grams in this case. And that's it for this problem. But I'm going to emphasize one more time, in this formula sometime you have to replace m or v. You have the density and find the third one. And in fact, you will see a very similar example is this one, where we have a chunk of metal that is dropped into a container, and you notice the water level rise by 1.2 centimeter. The container is like a square prism with a base of that measure 4 centimeters on each side. What is the density of the metal if its mass is 52 grams? So I'm going to try to draw a rectangular prism. I'm going to try to be an artist here. Maybe not. Something like this, I guess. This is the rectangular prism. The problem, maybe you want to do some dash lines, just like this one. Okay, let me be sure I do some dash line here, because you cannot see this line, and I think it's better. So this is the rectangular prism in the problem where the water is. We don't know how high the water is, and we don't really need that, but we know this is 4, this is 4. And let's say the water, and I'm gonna change the color to show water. This is the water. The water is right here at the beginning of the situation, but then you drop the chunk of metal, and then this goes up like this. It's gonna be here. So this is how much is the volume of the chunk of metal. So that's the thing we need to find out, that volume. And that volume will be area of the base times the height. That's one way to say it. The base is nothing else than a square. And why the square? Because these are 4 and 4. And we're going to do 4 times 4. That will be 16. And if you want in units, let's put square centimeter. That's the way we have. And the height, what is the height? The height is that 1.2 that the level of water goes up. So we have here 16 times 1.2. Okay, so remember the water goes up 1.2 centimeters. So let's do that in the calculator. 16 times 1.2. Oops, sorry. and that will be 19.2. What is this 19.2? The volume of 19.2 cubic centimeters. So now we know the volume of that metal by just measuring how much water the water moved up. So that is a good principle that can be used in real life. And now we can go and find the density because we know the volume of the metal. Okay, density is mass over the volume. So we know the mass is 52 grams. We know the volume, we found it, 19.2 cubic centimeter. And if you notice, we need to express the answer in this way. So no reason to do any conversion, just grab a calculator, 52 divided by 19.2, and that will be round to the nearest 10, 2.7. Now round it like this, 2.7 grams per cubic centimeter. Okay, so this is a very interesting problem. In fact, that's the way that Archimedes, and I pronounce in a different way than probably you hear it. It's a Greek guy, used in his life. You can find the story online if you want. Let's move to the second part of the lesson, and here we're gonna look to another way to use density when we have the density related to the area. What do we mean by that? Look at here. USA has a density of 36 people per square kilometer or 94 people per square mile. You notice the numbers are different. Why? Because the denominator are different here, square mile and square kilometers are. But density should be the same. It is the same. Germany, 233 people per square kilometer. Florida, our state, 401.4. New York, you see, we're not far away from New York. However, if you take a look, Jacksonville and New York, it's a huge difference. Now, I want to be sure this data was taken from online, and it is this year, 2023. So if you watch this in 2033, these numbers are going to be different. But my goal here is to see for you that the density in this case is people over the area. And you notice in here, people over area. It's a very good thing to do, and people sometimes need this density for different reasons. So now let's see some example like this one. This case on an observational study on Lake Kissimmee, they found there are 2,000 alligators. They know that the area of Lake Kissimmee is 5461 square miles. Can we find the density? This is a straightforward problem. Density in this case, the number of people, I said P, or the number of alligators in this case over the area. So in this case we have 2,000 alligators over 54.61. So let's do this division first. 2,000 divided by 54.61, and that'll be 36.62. I'll round it to the nearest 100. 36.62. What is this number? Very important to understand what is number. Alligator per square mile. So in other words, you expect if you go to this lake to get 37 alligator per square mile. In this next problem, we have John who wants to open a new restaurant, and he needs to follow the department regulation, which says require 11 square feet per person, and we need to find the maximum seating capacity. If the area of the restaurant is 2,875 square foot, so remember the formula. density equal pi over A, and you can get this formula from the problem. If you do not remember, in this case you see that 11 square feet per person. So in this case, let's take a look. We need to find the maximum number of people, so we're gonna have an equation here. In fact, it's not plugged in like some other problem. We know the density has to be 11 square feet per person. We need to find the capacity, how many people we fit in, and we know the area 2,875 square feet. So you notice I didn't put any unit, but we good. We have only feet, and that's a good thing. So how we solve this one? We had a very similar problem a minute, 2 minutes ago. We multiply by 2,875 to get rid of this guy, and we're gonna go do here the same thing. So let's see how many people we can fit in that restaurant in case we need it. It looks like they're gonna be a bunch of 2,870 feet times 11, and I end up with this 31,625. Oh, it looks more like a stadium to me. How many people can fit in that restaurant? Okay. So again, you notice here a problem where the D was given, A was given, and you need to find P. So be very careful. Let's take a look to the next one. We have Yellow River Park, who wants to increase the number of bison, and I want to bring 34 more bison. So we need to find the surface area needed for accommodating the new bison if the density is 15 bison per square kilometer. So again, the density equals P over A. What do we know here? We know the density, it's 15 bisons. We know the population, we want to bring in 35, and we want to find the area. So another one that we need to solve an equation, and the easiest way here, you can switch this 15 and A, these two guys, you can just switch them like this, and we have A equals 35 over 15. So let's grab a calculator, and I get 2.333. I'm gonna round this to the nearest 100, and I'll stay with 2.33 what? Square kilometers. So Yellow River Park needs to be sure they have this extra area, extra surface, to be sure they accommodate those 35 more bisons. And my last problem in this lesson is about this type of problem. You see here, we have a table, we have some cities, I call them A, B, C, and D, and we have the population of each city and the land area for each city. On part A, we need to find the city that has a density of 195 people per square mile. So what is the density in this case? Density is gonna be P over A, and we're gonna have to calculate it, all this density. The density of city A will be 18,801,310 over 53,927. So let's grab a calculator and do this division. 18,801,310 divided by 53,927, and I end up with 348.64. And again, let's leave it like that, 348 people per square mile for city A. So this city A is not the one we're looking for. Well, let's do the same thing for city B. What we're gonna do for city B to find the density, we're gonna divide 9 million. Let's not put a comma, like, because on the other one I did not put a comma. 9,535,000. 483 divide by 48,000, the land area, 48,711. And let's see how much this one is. Okay, I end up, this one looks 195 to me and some change, but I think this one is the answer. Okay, so the city B looks for me has this density of 195 people per square mile. Find the city with the smallest population. We need to find the other two cities. Now we know the density of A, the density of B. What about the density of C? And in fact, that will help us to really see if we did a good job on part A. The density of city C, what do you think we're gonna do there? 9,687,653. The population of that city over 57,000, the land area 906. Okay, so 9,687,653 divide by 57,906. I end up with 167 people per square mile. So looking now, it looks like city C has the smallest population density. However, we have one more city to check. Maybe the D is the answer. Who knows? The density of city D. What do you think that will be? 25,145,561 over 261,797, the land area of that city. And let me use the calculator. End up with 96 people per square mile. Okay, so let me double check this one more time. We have 25,145,561 divided by 261,797. Yeah, it's good. It's good. So yeah, look at here. The answer is CTD. DTD, even though it has a bunch of people, 25 million, the surface is a lot larger. Okay, a bunch of people at the land area is a lot larger. So look at here, the density is the smallest in city D. If you enjoyed this lesson, don't forget to click the like button and come back on C Square for more help. Thank you.